Hey folks, welcome back to another video. Today we're looking at question 410, split array largest sum. The way we'll be approaching this problem is by using binary search, and the binary search will be restricted to the greatest number which is in the array and the sum of the entire array. And the reason why we'll be searching between those two numbers is because even if you divide it into multiple pieces, the way you can minimize the largest sum is by choosing that one element which is the greatest. So if you're dividing it into m pieces, it will at least contain that largest element plus other elements as well. So since you know like the left and the right bounds, you can use that to find whether like the minimum largest sum. So let's jump into the problem and we'll see how that goes. Alright, so we need a couple of things. So we need the max and we also need the sum. So let's find that out. So to do that, we iterate through the array and then we check math.max of the current maximum and of the sum. Of the current number. And the sum, you would just add the current number to that. Yeah, that makes sense. Awesome. So once you have that, the one thing that you want to check if m is equal to 1. So that's one of the base cases, right? Yeah, so m can be equal to less than or equal to 1. So if it is 1, what you would do is you would just return the entire sum, because you cannot really divide it into smaller pieces. So just cast it and return the sum as is. If not, you'll have a while loop, and for that you need the left and the right bounds. So the left bound would be maximum and the right bound would be equal to sum, and we'll have a while loop here. Let's do, yeah. Okay, so why are these the bounds? Because anytime you divide them into smaller areas, you want to minimize the largest sum which is in those sub arrays, right? But how can you minimize it? At least the largest number you will have in the array, it has to be included in one of the sub arrays. And if you can divide it in such a way that the maximum number is a sub array by itself, so that is the minimum that you could possibly do. So that's the reason why it's minimum, and the maximum is a sum. Doesn't necessarily mean that sum would be like the value. It would only be the case if m is equal to 1. So the value that you're looking for is somewhere between max and sum. So let's jump right in. Classic binary search. You would look for, you would divide L and R divided by 2. And then you would check if, let's write this method right now. So let's call it as valid. So you need a couple of things with this method. You'd need the array that you need to pass. You would need to pass the mid, and actually this should be long. And this is into m pieces, right? So let's write that method. So it passes back a boolean and then is valid and a couple of things. So it would be int nums long target and int m. So what are you trying to do here? What you're trying to do here is you're trying to see if you can divide the array into m pieces where the largest value is equal to target. So let's do that. You would have int count as those would be the number of pieces. So we start off with 1, and long total would be equal to 0. So for int num in nums, you would check total would be equal to, you just add it the current number that you're looking at, and if total is greater than target, which means at this point the sum that you have so far has increased the target, so that's where you need to break the sub array. So you would increment the count by 1 and you would reset the total to be equal to num. So what that means is that anything before this number is a subarray by itself, because we don't want to cross the sum of subarrays more than target. And then the current element is where like the new subarray would start. And once you have that, you need to check if count is greater than m. So you're always keeping a count for whenever you start a new subarray. And if the count is greater than m, we know that it's not possible to create subarrays where the minimum largest sum is target. So if the current count is greater than m, you would just return false. So you just break the loop earlier and you return false, otherwise you would return true in the end. Awesome. So if it is valid, that means you could possibly try with a smaller number. So you reassign right to be mid minus 1. If this is false, that means you need to increase the left value. So it would be equal to mid plus 1. So left would be equal to mid plus 1. And once the while loop is done, you would just return the left value because that will be the minimum largest sum. And the one thing that we need to do is actually cast it because that's the type that we are trying to return. Awesome. So let's try compiling this and see if this looks okay. The first test case looks okay. Everything else looks okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is n log n. And the reason why that is because we go through the loop here, n, and then we also do binary search right here. It would be n log n. And space complexity would be of 1, since we are not really using any additional space to come to the solution. Awesome. If you have any questions, please let me know in the comments below. I would really appreciate you subscribing to the channel and liking the video because it really motivates me to make more videos. Thanks so much, and I'll see you all in the next video. Peace.